I want to do a quick study of this office building. First thing I'm going to do is, let's say, save this project as a file called study. So I'm ready to start working on it. I'm going to just use the default settings. I know this is in St. Louis, Missouri. You can see from the longitude and latitude here. If I look at the family, I know that what I've got is a building that in total is 40 feet high, and I know that it's placed on my foundation level inside the project with a floor already applied that cuts through, and you can see the values on here. So it's a little hard to see, but it's 12 feet above the ground level, so it's 2 feet, 12 feet, and then the whole building is 40 feet high. Now what I want to do is do the first study, and I'm going to use the default. So if I go to the Analyze tab and I go to the Energy setting, I'm just going to go with all the defaults that have been explained before. So one thing I want to make sure of here is that the schedule says default, so it's getting the schedule from the actual building type and not an override. So I'm ready to run that analysis, and I'll now say analyze the model, and I'll just show you that what I've got here is the surfaces. So if I let me just create the study. I'm just going to call it baseline. So I should have something called study, and then in that the first report is called baseline. And I don't have to wait for it to finish the report. I'm going to go straight up to the top here. I'll get a notification down here when the report's done, but you see at the top I can look at it in mass form, I can look at it as surfaces, I can look at it as zones, and I've also got this option that I explained before, is that I can look at just the components that make up the mass, like the internal walls. There's a little bug on the 2.5 where sometimes you have to adjust the view back to the default just to get rid of that kind of crazy looking perspective. Oops, sorry, it's because it's locked. So let me unlock it and back just like that so you can see. Okay, so the report's already finished, and what I want to do is I will at one point summarize all of these separate reports so that you can see what the consequence is of making the changes. But for right now, what I've done is a baseline report using the defaults for an office building. So here's the extracted values from the report. So for the baseline study, annual carbon emissions, if you look at the energy used in electricity consumption and fuel consumption, you get so many tons per year this represents of carbon emissions. You subtract from that the potential for the building envelope to generate electricity. So the assumption of photovoltaic potential at maybe a rate of about 15% efficient, subtracted from the energy used in the building, leaves you with the balance here of 374 tons per year. In terms of energy use, this is kind of the critical one to watch most of the time. 99,000 British thermal units per square foot per year. So over the 30 years of the building, that's the total here. If you associate with that the cost of the utilities locally, and you extrapolate, this would be the dollar amount over 30 years. Now if I look here at the actual reports, what's hard here, at least for me, is the fact that the top end of the highest value in the report and the lowest value in the report are not the same on both graphs, right? So you have to bear that in mind. Looking at the monthly heating loads, you're looking at the energy provided to maintain a constant temperature. I'm not sure exactly what it is, but say it was something like 68 degrees Fahrenheit or 70 degrees Fahrenheit. This is where you're getting a contribution towards maintaining that level of thermal comfort within the building from equipment, lighting, occupants and Windows Solar. Obviously you're getting a contribution from that in the winter month, this is January, from those internal sources, but you're losing energy, so that the minus values are energy that you're losing through the windows, primarily window conductive, but also walls and roof here. So you can see that there's a net loss in the winter months compared to what you're gaining in terms of heating that you're getting from the internal loads. If you look at the cooling loads, where you're thinking about what energy is being removed to keep a balance between the additions that you're getting from occupants, equipment and processes, is, again, if you look from the zero here, that you're going to have to balance with cooling, especially in the summer, right, where you're seeing the high values here that include miscellaneous equipment, light fixtures, occupants, Windows Solar, window conductive and infiltration. And you're getting not much of a contribution from window conductive, where you're losing some energy through natural processes in the colder months, right, through the walls and through the windows. So we'll come back to look at that. What would be nice for me would be if you could do something like this in the charts. If I could actually reduce that so it was more like at the 60,000 BTUs, so to match up here. And it's awfully hard for me to do this, but I'm going to drag it up, and you see I'd want the 120, I'd want 0 to be level with this. Let me see if I can move this down a bit. I think this would do it. So if I move this down so that 0 is about level with 0 here, and then I adjust this so that minus 50 is actually about there, so I'm crunching it like this. You see what I'm trying to do is I'm trying to show you that actually the significant problem is probably more on the cooling side than it is on the heating side, but you're trying to match like with like over here. 60 is about right through there, minus 100 is about right through there, maybe a little bit more like that.